Hello and welcome to Python for Musicians, a Python tutorial series for musicians of all levels. In today's video, we'll be looking at how to deal with live audio in Python. Before we jump straight in, we should maybe understand some of the key things that we'll be looking at in this video. The main one is that by live audio, we want direct access to the audio devices straight from Python. That means microphones and speakers, anything that's attached to our computer that we want to use, we want direct access to this. Then it's important to understand what portaudio is. So portaudio is a cross-platform library for audio input and output. It's also open source. My experience is that it comes in with Windows already, and you probably need to install it separately on macOS, and we'll look at how to do that. Lastly, we'll be using PyAudio in this tutorial. This is basically just a Python interface that speaks directly with portaudio on your computer. Okay, so jumping straight into Python, the first thing that you're going to want to do is have portaudio installed. Again, on Windows you might not need to do this, but for macOS the simplest way to do it is with homebrew. So if you don't have homebrew, go and install that. But if you do have homebrew, all you do is brew install portaudio and it should download automatically for you. Now I already have it installed, so it's just going to tell me that it's installed and I don't need to do anything. The next thing you're going to want to do, and this is for both Windows and Mac, is to run pip install PyAudio. Now I would normally run this, but I've tried this before and the basic install of PyAudio does not work for me, and I've seen a couple of users on the internet as well having the same problem. So the fix that I found for myself that you might want to do as well if you installed it in the same way as I have is to add these options over here. I'll also paste this in the description of the video if you just want to copy it from there. So let's run it and install PyAudio now. So this is interesting. A month ago this was not here, so you may not need the build option and things anymore, but I'll still include this command down in the description in case that you do need it. So let's dive right in. The first thing that we're going to need to do, of course, is to import PyAudio into our script. And then the main part, the way we use PyAudio is by defining an instance of a PyAudio class. So p equals PyAudio.PyAudio. So now that we have created the bridge between our Python script and portaudio, we can look at opening a stream. So let's say that our stream is equal to p.open. And open will create an instance of a stream. And you'll notice here that it's missing some arguments, including rate, channels, and format, among others. So let's define some global variables here. I'm going to set a sampling rate of 44,100, a block size of 256, and we're going to say that we want stereo, so 2 channels. So let's start populating this p.open statement. The first variable that I'm going to give it is going to be the format, and this is precisely the sample formats that portaudio accepts. So let me pull up the documentation here and see what our options are. Our options are PA float32, int32, int24, and all of these. Now my personal recommendation is to use float32, so let's do that. PyAudio.PA float32. The next term we'll give it is the number of channels. We have that already defined. We're going to give it the rate, and we also have that defined as our sampling rate. And our stream here is comfortable. It can start a stream with just this. But let's give it some more. One of the ones that we're going to give it is frames per buffer. This is basically our block size, so let's give that as well. Let's also say that we want input to be true, so we can get sound in. And let's also say that output is also true, so we can get sound out. Now, if we want to specify what audio device we're going to be using for input and output, this is where we do it. So it's also expecting input device index, and here it's expecting a number, and this is important. So let's put none for now, but we'll come back to this. And same with the output device index. I'm also going to put none and get back to it. Finally, it's expecting a stream callback. And this stream callback is a function that needs to abide by certain rules that will say what is happening when we are streaming. So here I'm also for now going to say none, but we also need to come back to this. Okay, so let's understand what they mean by input device index. To best explain this, I'm going to open an interactive Python session. You can do the same if you have IPython, or you can pip install it with pip install IPython. And then in this session, we need to quickly import PyAudio, and P equals our PyAudio instance. Okay, so now that we have our PyAudio instance, we can do p.getDefault output device info. This is a huge function name, but whatever. Hit run and let's see what it gives us. So it says here that the name of this device, the default output device now, is my MacBook Pro speakers, and it's index 5. Now by index 5, this is purely inside PyAudio's interpretation of my own devices. In a Mac, you can see what devices you have by checking the audio MIDI setup. And you'll see here, these are the devices that I have. And you'll see here, MacBook Pro speakers, the one that's my default for now, is number 3 in the list. So this means nothing. So we need a way to find out which index we need. So thankfully for us, this instance also has get device info by index, and you can give it an index, and also has a function called get device count, and this here says 8, and that's because I have 8 devices that portaudio recognizes. So we can create a function called find device index that will take in our PyAudio instance and the name of the device that we are looking for. The main point of this algorithm is that it's going to need to go through every device that is recognized and find the index of the one that matches the device name. So we can say for device index in range PyAudio instance dot get device count. So in this recursion loop over here, we want to check out every dictionary here and get the name of the device and compare it to the device name that we are giving into the function over here. So let's start that comparison with if. We're going to need to check the information that we give it. So PyAudio instance dot get device info by index, and then here we need to give it an index. So in this case we're going to give it device index. This should now return a dictionary like this. So with a dictionary we can immediately check for a key. In this case the key we're looking for is name, and we want to check if this is equal to the device name that we are passing in. And so if we have a match, we want to return the device index. So I want to be using this virtual device that I have created called example device. And it's got 2 inputs and 2 outputs. The 2 inputs are my computer microphone and my phone microphone. And the output is my computer speakers. I called this device example device, so we'll go device index equals find device index, and now it expects our instance of PyAudio, and it also expects the name of our device. So mine was called example device. So now I can dump in this device index in both these fields, device index and device index. Now onto our stream callback function. The stream callback function is going to be run by the streaming instance. So it needs to match the exact specifications. So I've pasted in a template callback function. There's absolutely nothing going on in here. But what's important is this. It needs to take in a variable called inData, frame count, time info, and status. I encourage you in your own time to check that you know what each of these things are, if you choose to need them. InData is the one we probably would need, and this is the data that's coming in from the input. So this is going to be ignored if your input here is set to false, but since it's not set to false, it's going to expect our in data. And what I've done is I've sent in our in data straight to the output. So nothing is happening here except that we're going to be sending everything that's coming in from the input straight to the output. You might be screaming in your head saying, but this is going to create feedback. And yes, that's exactly what's going to happen. So you need to be careful with this. Please do not use any loud things. Make sure that your volume is very, very turned down so that you don't get any problems. And at this stage, you probably could use headphones, but don't put them on. Keep them on the side in case there's something wrong here. So this callback function needs to also return a flag. And this flag can be one of three things. It can either be portaudio continue to tell that, we're going to send you more. PA complete and PA abort are basically, they do the same thing in this case, which is that they stop the stream. Now it's also important to note that this in data over here and this out data over here, well in this case in data, need to be in bytes. So you're going to get this in bytes, whatever happens. So before you do any processing to it, you're going to need to change it from bytes to floats and then back again. So for now, we're not doing anything to the callback function, but it's here. Let's now pass it as an argument inside our stream. So stream callback is now our callback function. So once we've done this, our stream should be open. So let's print the jolly statement and say stream open. So let's test this now. I've exited our interactive Python session so that we can run this script properly. And this should now open the stream. So we got some stuff happening here. The first is that it said the stream is open, except it doesn't seem to be open. And we got this trace trap over here. So two things about what's happening here. The first is that when you open a stream, you're opening it in a separate thread. And so what happens is that our main thread is now free to continue. And so that's why it comes here to this print. It prints stream is open and our function is done. It shut down the Python script when our stream was still open. And that's why we have this trace trap over here, because the stream is still open. So if we want to keep the stream alive, we need to keep the main thread alive. And there are several ways of keeping the main thread alive. The most common, if you don't want to be doing anything in the same time, is to just have a wait statement. So at the top over here, we can import time. And here where it says stream open, let's do time.sleep. So this is to keep your computer active or keep the stream active. And now it expects time in seconds. So let's say sleep for 5 seconds. And so what this is going to do is keep the main thread alive for 5 seconds. So basically our stream is going to be active for 5 seconds. Now we want as much as possible to avoid having this trace trap. So when these 5 seconds are over, let's close the stream. The way we do that is with stream.close. And while we're at it, let's terminate PyAudio. So p.terminate. So let's try this again. We're probably going to get some feedback now because now our script is complete. There we go. It's open. I don't know how much you are getting of that, but there we go. Our stream has opened and is now shut. So if we want to keep this stream open indefinitely, or we want to keep the main thread alive as long as our stream is open, we can do that like so. We can have a while loop. So the while loop is going to keep iterating until the condition over there is false. So stream has a method over here called isActive. So while the stream is active, please wait, and we can give it a wait time of 1 second. So let's do this again. So if I start this, it's going to start running, and it's going to keep running until I manually keyboard interrupt it. So the stream is open. Wap, wap. Okay, now we can interrupt the stream with our keyboard interrupt. Okay, so this is everything I wanted to cover about the stream itself. But there's still a big chunk to cover when it comes to how do we actually do any processing with this. So the first thing you're going to want to do is convert your in data from bytes to a usable array. So let's do that over here. So let's create a function here called usable array, and this is going to be numpy.fromBuffer, and now we can give it in data. And now This part here is extremely important because in data now is receiving floats as float32s because that's the format that we have given it over here. So it's important that our from buffer function over here understands that and creates a numpy array that matches this specification. So we do that with dtype equals np.float32. By default, this is normally float64. So if you don't do this, you'll be getting some funny behavior, especially when it comes to multi-channel stuff. And I'll show you exactly why in a second. So we now have our usable array. And if we go ahead over here and print the shape of this usable array, so usable array dot shape, remember that we have 2 channels of audio and a block size of 256. Now I'm not going to change the output just yet because you're going to notice that there's a problem over here. So let's run this script now, and I'm going to interrupt it shortly after we start getting some print statements. So notice that our usable array now is 512 by 1, essentially. And our block size is only 256. So we're actually getting both channels of audio in one stream. So we actually need to separate this into different channels. The way that it packs these arrays is it gives you the first sample of the left channel and then the first sample of the second channel. So it's giving you sample 1, sample 2, each one of different channels. Sample 3, sample 3, sample 4, sample 4. So if we want to use the left channel, you're going to need to specify every other number in that array. So left channel is equal to the usable array, and then you start from 0, the 0th index. You want it to go until the full array, but you want it to iterate in steps of 2. So if we now print out the shape of the left channel instead, we should now get 256. And we can do the same to the right channel. But this is a cumbersome process. And if you wanted to then process your data and then send this out, you do need to be sending one array. So let's, instead of having this usable array be one long stream, let's have it as channels. So let's create a function that's outside our callback function over here that is called getUsableArray, and keep our code nice and clean. So getUsableArray is expecting inData, and from inData we can infer everything else. So the first thing we're going to want to put in here is this over here. So usableArray is from buffer and float32. I'm actually going to call this as an array because I want to use the other variable. Let's now do usable array, and we're going to initialize this initially with zeros, and we need to have a specific shape. So we're going to give the shape of this zeros as block size by channels. So in our case 256 by 2. Of course we need to give it our d type of np float32 because by default it's 64. So now what we can do is iterate on a channel by channel basis. So for channel in range channels, we now need to generalize this bit of code over here. The way we do that is with our usable array. So our usable array, we want the entire row of the specified channel, and we're going to assign to that bit of our zero array in array, and then we need to index the specific samples that we want. And so we're going to need to go from the channel number and check that you understand why this is so, and then we need to go all the way until the end, but we need to iterate not by 2 but by the number of channels that we have. So this should be all for our getUsableArray. So instead of here using numpy from buffer, we're going to use our new function getUsableArray and give it inData. We can now remove this, and let's print the shape of our usable array. We obviously need to return our usable array, of course. So return usable array. So if we run this now, we get what we expected. So 256 by 2. And now we can then use our usable array over here, and we can immediately convert this to bytes now because, and it's only now that we can do this, because it has the same shape that we expect it to, and it has the correct data type that we expect. So if our data type was different or our shapes were different, then our samples are going to get jumbled up in different ways, and that can be really jarring. So if you have headphones or your computer volume is loud or something, please be careful, because it's really important that you do this in the right way. So now that this is set up like this, we can put usable array.toBytes, and we should be getting the same kind of feedback that we have been getting so far. Feedback. Okay, so now what we have done is we have created our callback function, and we have made it so that we can actually process the data that comes in as bytes in multi-channel format. The last step now is how do you do anything that's a bit outside the crazy stuff. So because in this function we only have this kind of stuff, the most that we can do in terms of processing here is something that looks a bit like this. So usable array times or equal to, so multiply the current array by about 0.5. And what this is going to do is basically a gain reducer. So if I do this now, the feedback gain is going to be much more controlled because it's being controlled from within. So the question becomes, how do we get external influence into our callback function? Now, the way that I've been doing it is using the audio processor class that we've defined in the previous video. And I'm going to do that over here. So I'm going to create a new audio processor class. So we define it as so. We'd expect like a sample rate, block size, channels, and in your process block, you can do all sorts of crazy things over here. So now we can define our audio processor at the start of our main file. So audio processor is an instance of our audio processor class, and we need to give it our sample rate, our block size, and the number of channels. And then we need to take the definition of our callback function and insert it into the main thread, so that here, instead of doing anything over here, we can run audio processor dot process block and then give it our usable array over here. And this is going to do exactly the same thing, because all I've done so far is do 0.5. But if you want to copy the audio processor from the previous video and do something there, or anything else that you fancy doing, this is how you would do it. You then do it inside over here, and then it will carry on into the rest of your stream. So let's try this, and you'll see that it now works. And the feedback, of course, is reduced because we have 0.5 multiplier on both. So in the next few videos, I'll be looking at creating oscillators and probably eventually filters and all these things inside here, so that we can start building up our synthesizer. And the way we're going to get live sound out of our synthesizer is using this PyAudio instance over here. We're going to turn input to false because we're not going to need the input, but keep the output as true. And we're going to be generating all our sound from this process block function over here. So that's coming in the future, but I thought for now I'll show you an example of how I used this audio processor in another project. And that project is live on GitHub. I'll link it in the description, but I'll also show it over here so that it kind of gets that context information that's necessary. So this is a project that I've done. It's called Feedback. And basically the idea behind this project was it was taking in sound coming in through the main device. It was analyzing it through a neural network, and then it was sending out synthesizer parameters to Super Collider. That's a different program. And so the audio processor over here looked like this. So it had the sample rate, of course. It had a neural network inside. It had some windowing, spectrum stuff. And then inside the process block over here, it was basically creating the usable stuff. You can see over here that we're getting the MFCC, which is basically a spectrum from the channel data. And then we were running this through our model here. So we were getting the params by running this through our model. And we were then sending out the channel parameters by OSC. And you'll notice here that the main thread is very similar to what we've looked at before. It's the audio processor class, and then it has the process audio. This is the callback function, basically. Same things over here. And then it had our from buffer, and we were sending that to the audio processor, and then we were sending out basically zeros because we didn't really care for the output. And indeed, we did put output false over here. And that's it. So I hope you found this video useful. If you know anyone who would benefit from this series, then please share it with them. You may subscribe if you like, you know, to get notified on the future videos, but that's entirely up to you. And you can leave a like if the video was useful. And yeah, you know the YouTube drill, so leave a comment, check the description, you know, you do you. So yeah, I'll see you next time. Bye.